My name is Jason Aramburu, and I'm the founder of Char. We are a renewable energy technology company that is developing solutions to fight global climate change. So I want to first show you two numbers, which you're probably familiar with. These represent concentrations of CO2 in our atmosphere. So right now, we're at about 387 parts per million. Leading scientists like James Hansen say if we don't get below 350 in the next 2 to 3 decades, we're going to start to see some of the really catastrophic effects of climate change. Things like flood, drought, famine. So which of our existing energy technologies can get us below 350? Well, it's not coal. Coal's responsible for most of those emissions. Nuclear is cleaner, but it's expensive. Renewables like solar and wind, these are crucial for slowing emissions, but they're not going to do anything for the carbon that's already in the atmosphere. So what do? Well, that's a question I asked myself when I was working in a clean coal technology lab at Princeton. I realized that clean coal is an oxymoron. Just getting it out of the ground is dirty. So I thought to myself, why don't we take these technologies and apply them to a cleaner fuel, like biomass, and make energy while sequestering carbon? So after a couple years of research, we developed a solution. And that solution is biochar. So biochar is just like the carbon charcoal you'd find in your barbecue grill, except biochar is made from waste. It's made from what's left over after we grow food, things like husks, pits, seeds, stalks. By producing biochar, we can make energy and sequester carbon. So how does that work? Well, in the traditional agricultural carbon cycle, plants take in CO2. We harvest those plants for food, and we're left with biomass. Traditionally, farmers take that biomass and mulch it or compost it. Eventually, the CO2 that those plants took in gets back into the atmosphere by decomposing. If we really want to fight climate change, we have to short out this system. Take those plants, turn them into biochar, and then bury that biochar in the soil from which it came. Now, for me to pitch this idea, I had to really know that it works, that what I'm saying is true. So I went to Brazil. About 1,500 years ago in the Amazon basin, indigenous farmers would take their agricultural waste, turn it into charcoal, and bury it in the ground. If you go to these sites now, you can see that that carbon they took out of the atmosphere is still in the ground 1,500 years later. To me, that's proof. Now, why would these indigenous farmers want to take charcoal and put it in the ground? They didn't know about climate change. Well, it turns out that biochar acts as a great soil amendment. This is a picture from one of our partners' trials in Cameroon. These are maize plants. We're finding that in the developing world, adding biochar to the soil actually improves crop yield about 200, sometimes 250%. So I said we're a technology company. This is one of our pilot plants. We built this for about $15,000. This unit can produce about 25 kilowatts of energy from waste. That's electricity, enough to power a village in Africa. It can also produce about 120 tons of biochar each year and can sequester 430 tons of CO2 annually. So where are we now? Well, we just completed a pilot demonstration showing that the technology works and that it works in the field here and abroad. From there, we want to roll this out on 3 continents. We want to show that this technology is applicable in Africa, Latin America, and places like the Midwest. Our goal is to get 100,000 tons of CO2 out of the air. From there, we want to roll it out across the globe. If we can get 2 billion tons of CO2, 2 gigatons out in a year, we could roll back emissions to pre-1982 levels in just 10 years. I was born in 1985. So for young people like me, if we can scale this, we can see a world that we've never experienced. So right now, I need your help. I need your help to get the word out and to scale this. If any of this resonates with you, please come talk to me. And we can make 350 a reality. Thanks.